Welcome back. Let's do 9b4. For what values of x is the inverse of g times the derivative of g divided by g of x be less than or equal to 0? So we have to recognize a few things here. Right. Let's start with the derivative of g of x. You don't need to stress about this and try to derive an exponential function. Remember that a derivative is what? Is a gradient. A derivative is a gradient. A gradient is the derivative. So now, let's look at the gradient of g of x. Let's look at the gradient of g. G is increasing. G is increasing. So it means that the gradient is positive. So g is increasing, meaning that the gradient is positive. The derivative of g of x is what? Is positive. We've dealt with the derivative of g of x. Let's look at the inverse of g of x. The inverse of g of x, this is the graph. The inverse of g of x, this one, you see that? And it is above the x-axis. The whole graph is above the x-axis. So again, the inverse of g of x is positive. So the inverse of g of x is positive. Now we're left with our denominator. Okay, we have our denominator g of x. This is one which will determine the values of x that we want. Right, for this whole thing to be negative, because less than or equal to 0 means should be equal to 0 or negative. So for this whole thing to be negative, therefore it means g of x must be negative. So where is g of x negative? Let's look at the graph g of x. Where is g of x negative? G of x is 0 here, and then it's negative below the x-axis. Below the x-axis. Let me just highlight that part. It is below the x-axis here. This is the part which is below the x-axis. And then the x values should be between 0, 0 and 1. This is where g is negative, between 0 and 1. So x between 0 and 1. So we have to be careful. It said less than or equal to 0. Less than or equal to 0. But we have an issue here. G of x cannot be equal to 0. G of x cannot be equal to 0. Because if g of x is 0, then this whole thing becomes undefined. So g of x cannot be equal to 0. So that's why we cannot include 1. That's why we cannot include 1. So 1 is not included. This whole expression is less than 0, is less than or equal to 0 when x is greater than 0 but less than 1. 1 not included, for the reason that if g of x is 0, it becomes undefined, so we cannot include 1. Let me explain this a bit. Right, we have the inverse of g of x, and then we said it is positive. And then we have the derivative of g of x, we said it is positive. And then now, for this whole expression to be negative, then g of x must be negative. So that positive times positive, that is positive, and then negative there, and then positive divided by negative, that's negative. If the inverse of g of x is positive, and the derivative is positive, and g of x is negative, then this whole expression will be less than 0. Okay, but there's this condition that 0 is also included. Between 0 and 1, that's where the inverse of g is positive and the derivative of g is positive and g of x is negative. So this is the solution. So you can write your solution like this, or you can say x is an element of 0 to 1 using the interval notation like this.